Hey team, it's Mr. Z, and today we're going to start our new unit. In order to kind of grease the wheels, we're going to review some concepts from our last module and then go ahead and step into new ground. Let's take a closer look, shall we? All right, so Module 3, Topic 2. The idea is we're going to be comparing linear and exponential functions. Number 1, determine the inverse of the function. So we've had practice finding the inverse of multiple equations. The idea at this point, we should recognize that f of x is the same thing as y, and it's going to be equal to x minus 4 to the 5th power plus 3. The idea with the inverse is I switch all instances of x and y, and then I'm going to have to use my inverses to isolate y. So I'm going to go ahead and use my inverse operations to get x minus 3 on the left to be equal to y minus 4 to the 5th power. The idea is that if it's to the 5th power, I can go ahead and take the 5th root to both the left side and the right side. What this is going to cause on the left is going to be the 5th root of x minus 3. And on the right side, it's going to just be the inside of the radical, y minus 4. I add 4 to both sides, and then it's going to result in the 5th root of x minus 3 plus 4, which is equal to y. My last step is to flip, and I have found the inverse of the original function. Number 2, list the functions used on the parent function 4 to the x to create the new function. So this is our new example. 4 to this is what we're studying in this unit. And the idea is that I can use my same rules to describe what's happening. So this 2 is going to cause a specific effect. This net minus 4 and this plus 3 are all going to have different effects. So the 2 in front means that I'm going to stretch vertically by a factor of 2. So minus 4, this is going to tell me to go to the right 4, and then I'm going to go up 3. So even though I don't know what the graph 4 to the x is, if I find out what it is, I can create a new function by following those 3 transformations. Use the function f of x is equal to 3 to the x power to fill in the table of values below. So I'm going to go ahead and start with 3 to the negative third. So when I'm doing 3 to the negative third, I just want you to know that when I'm evaluating it, I need to turn a negative exponent is going to be equivalent when it's in the denominator. So notice, 3 to the negative third is equal to 1 over positive 3. 3 to the negative second is equal to 1 over 3 to the positive 2. 3 to the negative first is equal to 1 over 3 to the positive 1. This is going to be equal to 1 over 27, 1 over 9, and 1 over 3. Now, filling out the rest, I can go ahead and do 3 to the first is just going to be 3. 3 squared is going to be 9. And 3 to the third is going to be 27. Hopefully you can see the pattern as I'm going to the bottom of my chart, 3 turns into 9 because I multiply it by 3. Likewise, 1/9 turns into 1/3 because I multiply it by 3. So what is going to be 3 to the 0 power? It's going to be 1. You can ask yourself, what number multiplies by 3 to be 3? 1. So here, this is going to be something, any number to the 0 power is going to be 1. The idea is, the reason is from this pattern. How do I turn a 1 into a 3? Multiply by 3. All right, so this was our warm-up to complete the step 1 of lesson 1. Let's get down to some nitty-gritty details. So comparing linear and exponential functions. The idea is with a linear function, all right, this is what we're used to. I can have a following examples. It usually looks like f of x is equal to mx plus b, while a exponential is going to be the basic function of a times some number to the x power. Notice in an exponential, the variable is in the exponent. Something I like to think about, the x is in the word exponent. For a linear function, we know that it is going to be a variable multiplied by slope and adding the y-intercept. Just like for linear functions, I can have positive, I can have negative, I can have up and down, and left to the right. For an exponential, I can have what's known as a growth, and then I can have what's known as a decay. This is what we're going to be studying in further detail. Just notice the exponential has an x in the exponent. That's what you should be taking away. All right. Helga and Johan each earn $10 a week doing chores for their neighbors. So Helga changes her payment from the neighbors to be a penny for the first week, and her pay will double each week after that. Okay. So, let's see who makes more money. Helga says she's going to be charged a penny, and then he's going to be making $10 a week. Now, the idea is that you might think, why would Helga take 1 penny? So, in the second week, it's going to double. So, it's going to be 2 cents and then $20. Next week, he makes another $10. It's consistent. Here, this is going to be 04. Next week, going to be $40 and 8 cents. $50, 16, $60, 32 cents, $70 and 64 cents, $80 and $1.28, $90, $2.56, and $100. I got $5.12. You can see for Helga's earnings, what we did was that we multiplied by 2 repeatedly. For Johan, we added 10 repeatedly. What parent function does Helga's earnings represent? This is going to be our new word. Since it's being repeatedly multiplied, it's going to be exponential because I repeatedly multiply by 2. It is exponential because she The reason it's exponential is, think about it. I have 2 to the first. That's going to be 1 week. To figure out how much she made in 2 weeks, she had to multiply by 2, and so on. This repeated multiplication is what leads itself to be exponential. Johan, on the other way, he is going to be doing linear because it's repeatedly added. Let's go ahead and write an equation to represent Helga's earnings after n amount of weeks. Now the idea is that this part, we have to write an equation. So I'm going to say the answer after n amount of weeks is going to be the initial amount, right, times the r factor to the n minus 1. So when I am writing it for this specific situation, Helga's earnings is going to be equal to 1 cent times r, which is going to be 2, to the n minus 1 power. Use the equation in part D to determine Helga's earnings for the following weeks. So I'm going to go ahead and use this equation. I have to figure out f of 15, which is equal to a penny times 2 to the 15 minus 1. This is going to be f of 15 is equal to a penny times 2 to the 14th power. This is going to lead me to say f of 15 is equal to $163.84. In 30 weeks, let's see. It's going to be a penny times 2 repeatedly. For 30 weeks, it's doubling over and over. So it's going to be 30 minus 1. This is going to reveal the statement 0.01 times 2 to the 29th power. And then this is going to produce the outcome. Okay. So the idea, notice how Helga was, or at first, she is not making anywhere near to how much Johan is making. A penny compared to $10. On week 2, 2 cents compared to $20. You fast forwarded to week 5 or week 10. Both of those weeks, Helga is making less money. The idea is that in 15 weeks, we can assume Johan is making 150. So this is the part where Helga, her pay structure, is finally going to yield more money. And then if this pattern continued, she would make $5 million by week 30. This is the power of repeatedly doubling. Exponential is repeatedly multiplying. What we are studying is repeated multiplication. Let's do another situation. So we have Quentin and Aisha. They're both doing chores. Quentin's earnings start with $1 on the first week, and he is paid 50% more. So he starts out with $1. Aisha starts with $5 in the first week and increases by $5 each week. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So Aisha will make $50 on week 10. Quentin, so he's going to get paid not double, but 50% more. So the idea is that I'm going to multiply each of these by 1.5 because it's 50% more. If I just took 0.50%, that would be less. So I'm going to repeatedly multiply by 1.5, and what I did here was repeatedly add. So this is going to produce $1.50. Then I'm going to go ahead and take $1.50, and then I'm going to times it by 1.5. Or if you know your way around money, half of $1.50 is 75 cents. So I take 75 cents and I add it to 150, and I get 225. Now I'm going to just repeatedly adding half or multiplying by 1.5, and this is going to be $3.38 after I round up. Remember, money is always 2 decimal places. And I do it again, and I get $5.07. $5.07 times $1, 1.5. So I just repeat this. I'm repeatedly multiplying it by 1.5. And you can see the amount of income is increasing steadily. And then voila, on week 10, she's making $38.55 doing chores. Again, you can see that from week 1 to 10, Quentin is not earning as much money originally, but the idea is that he will make more money in his future. The idea with this is just to understand your pay structure and know when pay raises are going to actually yield more profit. So Quentin, since we're repeatedly multiplying by 1.5, is going to be considered exponential. Because the original amount is being repeatedly multiplied by 1.5. Aisha is going to represent linear because the original amount is increased by 5 each week. So this is the hard part. How much would Aisha earn? Remember, the default equation is going to be f of x is going to be equal to the first term times the common ratio to n minus 1. So this means for f of n is going to be 1 times the common ratio, 1.5, to the n minus 1. And this is actually Quentin's earnings. Aisha's is f of x is going to be equal to mx plus b. mx plus b. Well, she's actually going to be making f of n is going to be 5 times x minus 1 plus 5. It's because that pay raise doesn't increase until week 2. She starts with $5, and then on the second week, she gets an increase of 5. On the third week, she gets an increase of 10. Do you notice how it's so important to have that minus 1 to adjust from week 1 and onwards? The same as for Quentin's earnings. If you were to continue it, f of 40 for Quentin would equal 7,371, 554 and 88 cents compared to 200. Notice how, again, that's a big difference in money. So the idea is that at first, Aisha was making more money. She probably saved more money. But eventually, with this salary structure, Quentin is on track to earn more money. This is why multiplying repeatedly has such an effect. And this is why the graphs we're studying are going to look like the following. They're going to be looking like they are exponentially increasing. They start off by slowly climbing, and then they skyrocket. This is what we're studying. We are going to be modeling exponential functions. All right, so this has just been the kickstart of our unit. Kind of gone over some of the big ideas. Let me know if you have any questions or help. I'm here for you all. Goodbye.